Okay, so real quick, we're going to look at the lessons 1 and 2 practice. These are pages 6 and 7. And it's going to be kind of two different ways. We're going to identify a bunch of features of our polynomials. Some of these will be based off of if we're given an equation. Some of these will be based off if we're given a graph. So to start on this page 6, we are going to look at if we have an equation. So the first thing that we're going to do for these problems is we're going to identify standard form. So we'll do like one problem at a time, and then obviously we're going to go a little bit faster for the next two. Okay, but reminder, standard form, you want your variables, or not variables, exponents going in descending or decreasing order from highest to lowest. So as I look at this one, I got a -1 and I got a 3x squared. Well, the positive 3x squared needs to go first because that's the next squared, and then I got that constant following it up. Okay, now remember, your degree is your highest exponent. So since my highest exponent is this 2 right here, that is a degree of 2. And because that is a degree of 2, how we classify that is a quadratic. Remember, that's classifying by degree, quadratic. You also have the number of terms. There's 2 terms. You call it a binomial. Okay, so it's technically a quadratic binomial. Now, number of roots is something that's going to be a little bit different on this page for each of these. But if you have an equation, we can find out the number of roots by matching it with the degree. These two should be the same. So if I have 2 degree, I have 2 roots. Now, these roots could be real or imaginary. I could also have double roots, okay? Or more, triple roots, okay? But I know that every single time, whatever my degree is, that should be the number of real or imaginary solutions. Okay, so that's what we're going to do for this section, and then we'll do something maybe slightly different for the graphs. Okay, now, turning points. My number of turning points is going to be, quick review, degree minus 1. Remember, this doesn't have to be the amount of turning points in my graph, but all right, this can be the max number of turning points. So if my degree is 2, that means the maximum amount of turning points is 1. All right, and think about it like a parabola, a U shape, 1 turning point there, right? Okay, then my last one's end behavior. Now, could I throw this into Desmos and take a look at the graph and then like determine end behavior? You can, but remember, you can determine end behavior from 2 things. All right, your degree, is it odd or even? And then your leading coefficient is what LC is going to be. Leading coefficient, remember, leading coefficient, all right, is what is the sign, or the leading coefficient is the number out in front, okay? Number out in front when it's in standard form. So look, in this example, my leading coefficient is 3. That's the leading coefficient. Okay, so if my leading coefficient is 3, all right, and my degree is 2, first of all, my degree is even, and my leading coefficient is a positive 3, so it's positive. So the even tells me that my arrows are going in the same direction. Okay, my arrows are going in the same direction. That means that these are either both going to be negative infinity, or infinity and infinity. It's going to be one of those 2. Okay, now the leading coefficient is what tells you which one's which. The negatives are going to be a negative leading coefficient, and then the positive infinity is going to be a positive. So since it's positive and even, that means both of these are going to positive infinity. I didn't really have to worry about the left and right here, even though I could. As x, arrow, negative infinity, that means x approaches negative infinity, so the left to the right. Then remember, this is like up and down. All right, where is my graph going? These are both going up because my degree is even, my leading coefficient is positive. Okay, so these are all things that we can identify just from the equation. So looking at the second example, all right, look at a couple things. I got negative 2x cubed, I got minus 4, and then plus x. So that negative 2x cubed is going to stay out front because the x to the third is my highest exponent. And then I got to follow up with the plus x, because remember, that really has an x to the 1, and then my minus 4. Remember, guys, the constants, just the regular numbers, it's like having x to the 0, but we never write that because that's just 1. So there's my standard form. My highest exponent is going to be the 3 right there, so degree of 3. All right, we can classify this. This is going to be a cubic, and remember, that's by degree. So if I wanted to classify this by number of terms, that'd be the cubic trinomial. And then the number of roots is also going to be 3. Okay, remember, these are the same. Okay, maximum turning points, I got degree minus 1. So 3 minus 1 give me 2 max turning points here. And then last thing, end behavior, okay? My degree is 3, so it is odd. And my leading coefficient is negative. Because remember, look, I have a negative 2x, okay? So there's my leading coefficient, negative 2. So odd and negative. So odd tells me that I have one arrow going up and one arrow going down, okay? So it's either going to look like this or like this, right? So one arrow going up, one arrow going down. And then the leading coefficient tells you which one. Since it's negative, remember, it's called a negative trend, okay? So a positive trend is going to go up from down to up, and a negative trend is going to go up to down. So if I look at the kind of the two examples I drew up here, okay, this graph has a positive trend because it's trending upward. This one's going down because it's trending downward. You can kind of think about it like slope, but it isn't slope because it's a cubic function. It's not linear. Only linear functions have that slope there. So that means I have a shape that looks like this if it trends down, meaning as x approaches negative infinity to the left and x approaches positive infinity to the right, as x goes to the left, my graph is going up to positive infinity. As x approaches to the right, my y is going down to negative infinity. Remember, you want one of each if your degree is odd. And there's my end behavior. Okay, so then our last example here, it's pretty bare. Look, it's just negative x to the fourth. So standard form, I'm just going to leave it like that because that's the only term. It's a monomial. My degree is going to be 4, which makes this a quartic. And same thing, I already mentioned, it's a quartic monomial, one term, it's a quartic. My number of roots, 4. Turning points, degree minus 1, so 3. And so then my end behavior, if our degree is 4, that makes it an even. And my leading coefficient was negative, okay? Because it was a negative x to the fourth. Remember, that's like a negative 1x to the fourth, but we never have to really put that 1 there in that situation. So it's negative. So remember, even means they're both going to be positive infinity or both negative infinity, and then the negative tells me they're going down. So it's going to be negative infinity, negative infinity. Awesome. So that's all based off of the equation. So to finish up here, I look at these ones. All right, so now this time when you have a graph, notice how the first question is kind of different. What is the number of real roots? Real roots right here. Okay, so guys, real roots are going to be your x-intercepts. You can't see imaginary roots, okay? And you also might have some that are double roots, triple roots. We'll talk about that in a future lesson, okay? But like as I look at these graphs, obviously looking at the number of x-intercepts, how many times do I hit the x-axis? In this case, it is 2. Now, take a look at the number of turning points. My number of turning points here, okay, all right, is where the graph switches. So look, as I go down and it switches up right that, then look, there's one turning point. If I go up, it switches right there. There's a second one. And then I go back and it switches one more time. There's a 3, okay? So there's 3 turning points here. So this is where you got to kind of be careful. Potential degree. Now, I know in the last section, we kind of always matched up degree and degree and roots, okay? The problem is I only identify the number of real roots, all right? There could be more that are imaginary, or some of these roots could be double roots, triple roots, etc. Okay? So I don't necessarily want to always match up like my number of x-intercepts with the number of, or my potential degree, okay? That won't work out. Instead, you can use your picture, you can use number of turning points, you can kind of use multiple things. So guys, remember, if turning points is degree minus 1, then if I take that 3 and I add 1 with that, all right, then it kind of gives me a 4. Now let's think about this. Does that answer make sense? 4th degree. Well, let's look at my end behavior. My end behavior, my arrows are going up. So they're both going the same direction. So that means my degree has to be even. Is my degree even if it's 4? Yep. Okay. So I feel confident that my potential degree is 4. That just means that there's either 2 imaginary solutions, or maybe some of these x-intercepts are double roots, triple roots, which, like I said, we'll talk about in a future lesson. Okay, now my 2 arrows on my end behavior are going up, so that means my leading coefficient is positive. And you can kind of just use your picture to help determine that if both of your arrows are going up, then that means you're going to positive infinity, positive infinity. And there's all the questions we can answer for that graph. So to keep going, let's take a look. Number of x-intercepts, 1, 2, 3, that's a little tough to see, sorry. 4, 5 real roots, x-intercepts there. The number of turning points is going to be 1, 2, 3, 4. So same deal, looking at potential degree. This time, all right, I'm going to look at turning points. If I add 1 to that, it'd be 5. And let's just double check. Does 5 make sense? Well, 1, I have 5 real roots. So, like, this one actually does kind of match up to that. But 2, look at my end behavior. I have 1 arrow going up, 1 arrow going down. So my degree should be odd. I think 5 works here. Okay, leading coefficient. So this kind of goes with end behavior. But my leading coefficient, if I start with an up arrow and I'm ending with a down arrow, look, that is trending down. That's a negative trend. So it's a negative trend, so that means that my leading coefficient is negative. And then, remember, x approaches negative infinity to the left, x approaches positive to the right. So as my graph goes to the left, it goes up to positive infinity. And as my graph goes to the right, it goes down to negative infinity. And there's my end behavior there. So to finish up this page, all right, last one here, number of x-intercepts. You only see 1 here, so I got 1. Now, number of turning points, so this is kind of interesting, okay? The number of turning points here is 0. Like, look, there's no turning points. It goes up, it kind of mellows out here, but then it keeps shooting back up. It never shoots back down at all. Okay, so my number of turning points is 0. So here's the interesting thing about this is when I go to potential degree, if I just do 0 plus 1 again, all right, if I answer this as 1, that doesn't really make sense because look, 1 is a linear, just a line. This is clearly not a line. Okay, so while 1 might make sense for the degree minus 1 and then there's, once again, roots here, the problem is, all right, the problem is that it doesn't really fit with the picture of my graph, right? Now, if I jump up 1, 2, does 2 really make sense here? No, because a degree of 2 is going to give you a parabola that either opens up or down. And same thing, like both of those arrows, every parabola, the arrows going in the same direction. My arrows are not going in the same direction here. They're going in opposites. So that's why I'm going to say that this potential degree is 3. This picture is a cubic picture. Now this just means that, remember, turning points, that degree minus 1 is for max number of turning points. So be careful with that. It doesn't always match up as degree minus 1. It's just, hey, what's the maximum you can have? There are cubic functions that do have 2 turning points like that, 1, 2. Okay, it's just this one didn't. All right, it's kind of the same thing with like roots, with how, yes, the number of roots and degree will match up. This will have 3 roots. It's just that they're not all real, and graphs only show you the real roots. All right, so had to be a little careful with that with potential degree. All right, so my leading coefficient, so since it's an odd degree, same thing, it's going to be a positive negative trend. This arrow starts down and ends up, so that is going to be a positive trend as it goes up. And so since it's a positive trend, remember this is left, this is right. As I go to the left, I go down, negative infinity, and as I go right, I go up to positive infinity. So once again, a little couple of different questions you can answer differently, depending on if you have the graph versus if you have the equations. But all this information you can get from either the equation or your graph here. So here's page 6 of our review.